Core Data's optionals are quite different from Swift's optionals, which makes them rather uncomfortable to work with. In this video, I'll walk you through 2 ways of fixing this problem, which will help clean up our code nicely. Like I said earlier, Core Data's optionals are not the same as Swift's. If you make a core data attribute non-optional, i.e. required, it can still be nil for as long as you want. It can still have no value for as long as you want, as long as by the time you call save, it does have a value. That's the requirement. Whereas in Swift, a non-optional must have a value at all times. Now, when you're dealing with very simple core data implementations, or if you're just learning, the most common way to remove this core data optionality is just to kind of hack it out by hand. I'm going to show you how that's done, how it looks, but I don't want you to follow along. I'll show it to you here. Don't follow along later when I tell you to. This technique might work well enough in small things, testing things, but it comes with various downsides I'll touch on afterwards, so please don't follow along. So if you want to hack the optionality out of your core data, you'd start by opening up your core data model here, this thing. You then bring up the data model inspector here and select your entities, issue and tag. You then change code gen from class definition to manual/none. So we're saying rather than having Xcode generate classes for us, don't do that. We'll do it ourselves. It's manual code gen. We'll make instead real classes with real code we can edit. To do that, you go to the editor menu, then choose create NS managed object subclass. Select main, press next, select issue and tag, press next, and then go where you want the files, like in here, for example, into my folder, my group, then press create. And you'll see these 4 files get created. Again, don't actually do that here. I'll be backing out of this change shortly. When this process finishes, you'll see we have 4 files made for us by Xcode on the left here. We've got a class and a properties file for issue and tag here. And each thing has 2 files. Each entity has 2 files for a reason, because it gives us some degree of customization. This properties file contains all the functionality core data needs to work. There's a title, a content, a priority, completed, plus that fetch request thing for loading issues, all of them. Some helpful things down here for adding and removing values. And then the class file is empty. And that's helpful because we can add our own code there and customize that bit of the code freely, leaving core data to handle all these managed properties over here. This distinction really matters because if you make changes to your core data model later on and regenerate these subclasses, it'll only overwrite these 2 properties files. It'll leave the class files alone, along with any changes you've made to them. They're left intact. What we care about here, though, are these property files. And inside here, this is the issue properties. You'll see about 40-ish, 30 lines of code, including, I said, the title, content, priority, all the way down here. And you can see the optionality right here. It's not a string, it's an optional string. It's not a date, it's an optional date. And you'll also see, by the way, NS managed, which looks like it's a property wrapper. It's actually not. It predates property wrappers by a long way, sadly. It's a special hard-coded Swift value, meaning core data will handle this for us. So rather than completed being a trivial Boolean in memory, it'll actually automatically read and write that Boolean value from the database, tell its context when changes happen, and much, much more. Now, here's where the hack job comes in, because many folks will just say, actually, I'll just delete these question marks like this. Boom, down the line. And honestly, that sort of works, right? You can now read title directly rather than trying to use nil coalescing. Same for content, same for creation date, modification date, and similar. There's no more nil coalescing required. However, while this solution might work well enough for learners or for small toy projects, I think it causes a bunch of problems in the long term. First, from a Swift perspective, using non-optionals here gives you some certainty you don't actually have. Like the underlying data here might still be nil. It's core data's managed data. It might still be missing. You've said it won't be, but it's not your choice. It's core data's choice if it's there or not. So you try to force a nil thing into a non-nil container, and who knows what'll happen. You know, in regular Swift code, if you have a non-optional, it's guaranteed to have a value at all times, right? But here, I have no idea what you'll have. It might work just fine the first time, or the first 1,000 times, but then inexplicably break in production on a particular device configuration. You just can't tell. Second, every time you modify your data model and regenerate your struct, your class, it'll recreate the optionality for you. It'll reinsert all the question marks, undoing the work you did. And this, of course, causes problems. You've got to redelete the question marks every single time. And this actually goes the other way too. If Apple actually improves their class synthesis in the future, you won't get those improvements unless you recreate the class. Third, reading the tags attached to an issue is done through an optional NS set, which is hideous, quite frankly. It's absolutely awful. Not only do we have to use optional chaining just to read the set, but this NS set doesn't know the type of data it stores. It's not an NS set of tags, for example. It's an NS set of anything at all, which is useless. So we have to do an optional typecast and then use nil coalescing to provide a default value safely. The final reason why I'd be careful with this approach and really avoid it is just to remember you are now screwing around with core data's internals, right? It expects these properties to be optional, and changing them under its feet doesn't seem like a good idea to me. It might work for the next year or two, but what if something changes in the future? So we're not going to use this approach here. Instead, I'm going to go ahead and select these 4 files in my project and delete them, move them to the trash, get them out of the way, and then put in my data model, issue and tag back to using the class definition code gen, just like we had earlier. The same code, lots of optionals are still in place, the same programmatic code. Now, if I want to work around core data's optionality in a safer, more maintainable way, I nearly always prefer to do so using extensions that wrap all the nil coalescing up in one place. This is the approach we'll be following here in this project, so please follow along from now on. The bad part's gone now. Start by making a new Swift file, Command N, and calling it issue-core data helpers.swift, like that. And I'll put it above the data model like that. And inside here, we're going to go ahead and add an extension on Xcode's auto-generated issue class. And I'll say this thing has an issue title, string. When we read it, send back title. If it's nil, send back empty string. When we're writing it, set title to be new value. When we have our issue content, that's a longer description string. Again, reading it, send back content or nil, empty string, and writing it, content is new value. Then we have our issue creation date. That's a date. That's going to be easy to write. Easy to write. It's already built into it, but reading it we can just do here. We'll do creation date or .now, and then issue modification date. Date is our modification date or now. Like that. And this is similar to the work we had done before in sidebar view over here, unwrapping things with the right IDs or names, whatever. Very similar here with important changes. First, we now have getters and setters for the title and the content. We can modify these things directly, but also all the optionality is resolved in one place, in this file here. The whole rest of our project hasn't got to worry about core data optionals. They're all cleaned up here. And we haven't got a setter for creation date and issue content. They aren't needed. They can be assigned to directly. Now, realistically, when this code runs, there is no performance difference between this and having the traditional inline nil coalescing code. We're just putting it in one place, out of the way. It makes it much, much nicer to work with, and that counts for a lot. Now, you might notice I've got a simple but consistent naming style for these extension things here. My type is issue, and so every property starts with the word issue. Issue title, issue content, and so forth. This makes it really easy at a glance to tell which property is the original without the word issue and which is the extended unwrapped helper with the issue in there. While you're here, I'm going to add an extra property here, a static example property that creates an example for SwiftUI to try previewing with. And this can build on the in-memory initializer for our data controller. So the examples are only temporary if they work. Again, previewing is really hit and miss with core data, but we're going to give it a try. We'll say static var example is an issue. This makes a new controller using in-memory true. Gets its view context out. So controller, container, view context. We'll then make an issue inside that view context and provide some sample data. So we'll say issue.title is example issue. Issue.content is this is an example issue. Issue priority is 2. Issue.creation date is now. And then return issue. Send that thing back to be used inside previewing like that. So that example, again, even though core data frequently makes previewing nightmarish in SwiftUI, we're at least going to try. So if we find a workaround later on, we can put it in place. As an example, things our code compiles cleanly. And that's our issue helpers done. So now let's turn to the same thing for tag, press command, then make another new file. Call this thing tag-core data helpers.swift. And give it this code. Extension on tag. What a tag ID, UID. That'll be ID, and they'll coalesce to UUID. Like that. And then tag name is a string, name, it'll coalesce, nothing at all. And that does much the same thing as with our issue extension. It sends back the current value if it can, or a sensible default value, new UID, or empty string here. We don't need setters here because tags are much simpler to work with than issues, as you'll see later on. Also, as with issue, we're going to add a static example tag here, create a sample tag for using in SwiftUI previews if they want to play ball. So go ahead and add this code now. Static var example is a tag. Let controller be a new data controller in memory. Oops, crazy. Memory true. Get its view context out. Like that. Make a tag inside that context. Our view context. Give it an ID. Give it a name. And then send back the tag. And these two fairly simple helper files already do a lot to clean up the places where SwiftUI and core data meet. But there are still two conspicuous speed bumps in the road, and they are these NS set instances you saw earlier that describe the relationships between issues and tags. So what we have already allows us to clear up our project quite a lot. But I want to add more properties here that make our two NS set properties easier to work with. First, we're going to add something to our issue class over here that gets all its tags neatly sorted. We can say as a property, var issue tags returns an array of tag. Our result will be our NSSet, again, it's optional chaining, dot all objects. So you can see it returns an array of any. Terrible. Save typecast to array of tag. If that fails, or if there are no tags, nil coalesce to an empty array, and send back result.sorted. So it's wrapping up all this NSSet horror, all that mess in one place right here. We have optional chaining happening here, conditional typecast, nil coalescing, all in one place. And this is great because it just gets that junk out of the way. Let's focus on the nice stuff. We just say issue tag, boom, the array comes back. It also sorts the array so that tags always appear in a consistent order on the screen. And that part, you can see, is currently not working. Swift doesn't know how to sort tag objects. And to fix this, we're going to make our types conform to the comparable protocol. So it knows how to sort issues and how to sort tags. And how you sort these things ultimately is down to you, okay? But the most important thing is that your sort is stable. Given input A, your code should always produce output B every single time. It shouldn't fluctuate even slightly, otherwise your UI will get confusing as things moved around randomly inside there. Now for this project, I'm going to sort issues by their title, if possible. But if two issues have the same title, I'll actually sort by the creation date instead, so we still have some kind of stable sort. Again, it'll keep things fixed in the same order as we leave it there. And so to do that, we're going to go into our issue core editors helper thing below the extension, add a second extension on issue to conform to the comparable protocol. This is one requirement. You've got to implement a public static func less than function. On the left of that thing will be an issue. On the right of that thing will be another issue. And you want to return Boolean true if the left-hand item should come before the right-hand item. So we're going to say inside here, our left item is a left-hand side's issue title, localized, and we want to look for localized lowercase, get it in lowercase based on the language. Our right will be RHS, issue title, localized lowercase. And if left is equal to right, they have the same text somehow, we'll sort by creation date. So we'll say LHS issue creation date is less than RHS issue creation date. But if left and right are different, easy, we'll sort on that is left less than right. And now issue conforms to comparable. The other set is inside a tag class where it stores all the issues attached to a particular tag. This time it's something slightly different because we'll be using it to show only active issues right now, which issues that have not been marked as completed. And so inside tag core data helpers.swift, we'll add a property in here, var tag active issues is an array of issue. This thing will go ahead and grab all our objects, again, that messy optional chaining, conditional typecast, and then nil coalesce to empty array. So our result is object issues, optional chaining, all objects, conditional typecast, issue array, nil coalesce, empty array, and return that result, filtering with $0 completed is false. They are not completed right now. And we'll also make tag conform to comparable, just like how with issue. Again, it's important this thing be a stable sort, so our tags don't change order by surprise. So we'll make this thing use a tag name if possible, otherwise the tag ID. Now, yes, we're sorting by UUID order. It doesn't matter. The user won't see it. All we care about is it's a stable sort. It will not move around the screen by random. So we'll say below here, as an extension on tag for comparable. Again, public static func less than LHS tag, RHS tag returns bool. Our left is LHS tag name dot localized lowercase. Our right is LHS tag name localized lowercase. If left is the same as right, then we'll return LHS tag ID, UUID, as a string is less than RHS tag ID, UUID string. Again, a meaningless comparison, but it will ensure a stable sort. Otherwise, we'll do left is less than right, like so. And that should complete our core data helper code. I made some typo perhaps, thinking a little bit. You think you're going around, I can't tell. It's building slowly, you can do it. There we go, it got there, fine. So core data helper code's hopefully correct at this point. I'm going to type quite a bit, we'll see shortly. With these changes in place, we can actually head back to sidebar view now and apply it to our code straight away, because this nil coalescing can now come out. We can say tag.tagID and then tag.tagname, and it will work much nicer. And that's the same work we had before, the same nil coalescence happening before, except now we can make sure our issues are always sorted ahead of time and sensibly and stably, and make sure any default values are stored in one location, not scattered through various views in our project. Having these helpers in place will make it much easier to build the rest of this project. It's really, really nice. In fact, we can get one quick improvement very quickly. In sidebar view, we could find this for each of tag filters, and we can add a modifier to the label for our tag filters here, saying there's a badge for this thing, for this item here, and we can say get this filters tag with tag active issues dot count. So how many active issues are inside this thing right now, or nil coalesce down to 0 if there is no tag, like that. And that will show for us the number of active issues belonging to each tag right there in the sidebar. So if I press Command R now, we should see some data. Let's find out. So let's go back, and boom, 57436. If you remember, I used, I think, just bool.random for the completion status, which is why it's completely random. So you can see it's telling us, well, tag 1 has 5 open issues right now, and tag 2 has 7, and tag 3 has 4, and so forth, which is really, really nice. And so we already have code now to create a bunch of sample data with tags and issues, and hopefully you can find these badges represent something sensible for your particular local data.